approximate to the nearest 0.1 degrees all angles theta in the interval 0 degrees to 360 degrees that satisfy the equation sine of theta equals negative 0.5640. Well, what we'll do is think about this on a unit circle, and on a graph of the sine of x, which has this shape. Sine of 0 is 0, sine of 180 degrees is 0, sine of 360 degrees is 0, and then we have peaks at 90 degrees and valleys at 270 degrees and a number of other points as well, of course. Those all correspond to points on the unit circle. We can see that the sine is 0 at 0 degrees because the sine gives us the y-coordinate for the xy pair. The sine will then also be 0 at 180 degrees, right, as we go this way, and then 360 degrees as we wrap around, and then every time we circle around the unit circle we'll get another 0 on the graph of the sine of x. Now we're supposed to find a value for theta for which the sine of theta is negative 0.5640, or just 0.564, which is to say that we need a value of theta corresponding to the inverse sine of negative 0.564. Because 0.564 is not a value that we commonly know the value for the inverse sine, we can, or for the sine of theta rather, we can just use a calculator to do that. We'll type inverse sine of negative 0.564 into the calculator, and that gives us negative 34.3 degrees if I round to the nearest tenth of a degree for a value for theta. Now that would correspond to an angle approximately here on the x-axis for this graph of y equals the sine of x. It would correspond to an angle on the unit circle of a negative 34 degrees, 34.3 degrees I should say. And we're supposed to find answers in the interval from 0 to 360. Well, to do that, we can first transform this negative 34 degree angle into a positive angle by subtracting that from a full revolution. So if you do 360 degrees minus the 34.3 degrees, that will give us one value of theta that can work. I'll call that theta 1. With a calculator or doing some mental math, we can work out that that's just 325.6 degrees for our theta 1. That's one of the answers to this question. There is, however, another angle that will work. If we're, and I should have pointed out that that angle corresponds to a point approximately here on our sine curve, 325.6 degrees. But you can see there's another value, another point on the x-axis, or another angle for which the sine will give us the same y value, the same output. We can find that on the unit circle as well. The reference angle of 34.3 degrees here corresponds to a 34.3 degree reference angle here, and since the sine gives us the y value of the coordinates on the unit circle, the y values for these 2 points will both be the same, and we can work out the angle that will start at 0 and wrap around to this terminal side by adding the 34.3 degrees to 180 degrees, or a half revolution. So a theta 2 that will work in this case is 180 degrees plus the 34.3. That gives us a value of, what, 214.3 degrees, and that is a second angle for which the sine of theta is approximately negative 0.564.